Calculating second moment of inertia and section modulus for other profiles than simple basic profiles needs a process, and for that process we have a name called parallel axis theorem. The process how we calculate the second moment of inertia and section modulus for profiles other than rectangles and circles, for example, goes so that we have to first find out the neutral axis. In other words, we have to find the center of the mass of that cross section which we want to calculate. After we have solved where does the neutral axis locate, we can then calculate the second moments around both of the neutral axes. We can calculate around y-axis and z-axis. And in order to calculate that one, we're gonna need so-called Steiner's rule. There's also a method called subtraction method, but that we're gonna go through in another video. So let's start the process of calculating the second moment of inertia for this profile in here. So first thing to do is to solve the location of the neutral axis of this profile. And for that one, we can use the rule where static moment of divided areas around additional y-axis equals to static moment of the total area around this additional axis. And when we want to solve that location of the neutral axis, we started by first doing a so-called additional axis for our profile. In this case, we have located the additional axis to the top left corner. So the origin here is in here, and we have drawn here the y additional axis and the z additional axis. After that, what we do is we have divided the area into simple basic shapes. The division to the simple basic shapes is needed when we want to solve the locations of the neutral axis of these divided areas. So here we have area 1. So we have divided this into area 1 and area 2 in here. So now when we are using those very basic simple shapes, we can easily directly see where the center axis for these simple shapes locate. For example, for area 1, the location of the neutral axis or the center axis is 1.5 millimeters from top, because this is 3 millimeters tall. For the area 2, the location of the neutral axis of this area would be in here. So that's how we can define those. Now, using this equation, z0 equals area 1 multiplied by distance z1, which is distance here, plus area 2 multiplied by the distance z2 divided by the total area is the distance to the neutral axis of the entire profile from your additional axis. Okay, so using this equation, we can see from here that area 1, 3 millimeters by 3 millimeters, 3 millimeters by 3 millimeters, multiplied by the distance 1.5 which is the distance z1 here. So from additional axis to the center of this area 1. Then we add there area 2, which is 1 millimeter wide, 6 millimeters tall, so 1 millimeter by 6 millimeters, multiplied by the distance z2, which is the distance from additional axis to the center or the neutral axis of area 2. And now we divide this entire thing with the total area of this profile, and we get that the location of the neutral axis of this entire profile is 2.1 millimeters away from the additional axis YA. Exactly the same thing can be also done to solve the location of the z-axis. So Now, instead of calculating around towards the y-axis, we just have to calculate towards our additional z-axis in here, and the equation goes like area 1 multiplied by the distance from the additional z-axis to the neutral axis of area 1, which is here, multiplied, and then we add there the area 2 multiplied by the distance from the additional z-axis to the center of area 2, which is 0.5, and we divide that by the total area of that cross section, and we get value of 1.7. So now we know where the center axis or neutral axis of this entire profile is located. It is 1.7 millimeters from the left side of the profile and 2.1 millimeters from the top of the profile. After that, when we have solved the location of the neutral axis, we can proceed to solving the second moment of inertia of this profile. How we do that? Well, for that one, we're gonna need this equation in here, which is now the parallel axis theorem. In this equation, we have sum of second moment of inertia of each of these areas multiplied by term y. We have the second moment of inertia of each of these areas around their own neutral axis, which is this term in here, and we add there the area multiplied by the distance of the area's neutral axis to the neutral axis of the entire profile, power to 2. It is a bit confusing at the beginning, but let's take a closer look with this example. So in here, we first have the area 1's second moment of inertia around its own axis, which is 3 millimeters width multiplied by 3 millimeters, which is the height, power to 4, so 3 power to 4, divided by 12, plus area 1, 3 millimeters wide, 3 millimeters high, multiplied by the distance from the neutral axis of the entire profile to the neutral axis of that area, power to 2, and in this case it's 0.6. And then we add the second moment of inertia of this area 2, which is 1 millimeter wide, 6 millimeters tall, power to 3, divided by 12. So this is the basic equation for second moment of inertia. And we add there the area 1 times 6 millimeters multiplied by the distance from the neutral axis of area 2 to the neutral axis of the entire profile, which is 0.9 millimeters. And by that way, we finally get the second moment of inertia for this particular area cross section. When we want to calculate the section modulus, we just simply divide the second moment of inertia with the z max, which is the maximum distance from the neutral axis of the entire profile to the farthest point of that profile, and in this case the distance from the neutral axis to the bottom here is 3.9 millimeters, so we divide it by 3.9 and we will get a result of 10 millimeters power to 3 for the section modulus of this profile. In the same way, we can also calculate the second moment of inertia around the z-axis. We use the same formula. The difference is that when we calculate the second moment of inertia for these areas, we just have to calculate it around the z-axis. The difference can be seen in here. So in here, for example, now when we calculate it around the z-axis, we can see that the width is now 6 millimeters and the height is 1 millimeter. And also in these Steiner terms, this parallel axis theorem terms, we can see a difference that the distance from the neutral axis of this area to the neutral axis of the entire profile is 1.2 millimeters. And what we get is that the second moment of inertia of this area of this profile around the z-axis is 21.7 millimeter power to 4. So that's how you calculate second moment of inertia and section modulus for cross sections that are not thin-walled or open profile or thin-walled closed profile, or not one of those simple basic shapes. In following examples, we're going to be calculating some of these second moment of inertias for some profiles, so stay tuned.